Hello and welcome to the July 2025 Learn with the Nerds event with yours truly, Zane Goodman. Today is an exciting day because we are diving into a brand new Learn with the Nerds topic, Python. Specifically, we will be focusing on what you need to get started analyzing data using Python and Pandas. Now, of course, the world of Python is massive, it's vast, and there is a lot to learn, but don't worry, because we're going to be covering the basics of data ingestion, cleaning, querying, filtering, merging, and aggregating. We'll even take a look at visualizing one of the insights that we find using matplotlib. For today's event, we will be jumping right into what's called a Jupyter Notebook, which is the tool that we'll be using to write our code. And the best part is you get to follow along without downloading anything except the files that are linked in the description. Now, make sure you go ahead and get those downloaded before we continue. Now, before we get started, I want to talk to you about why you might want to use Python for data analysis. Starting with number one, it's easy to learn and use. Now, this isn't me taking away from the difficulty of what it looks like to learn Python or any other language that's out there. It's more so that there's a lot of helpful pieces of Python that will make it easier for you to learn and use. For example, you have readable and intuitive syntax. Python's syntax is very clear and readable, especially after you get a good foundation in it. It makes it a lot easier for beginners to learn and for experienced data analysts to quickly write and understand code. Number two is extensive libraries and frameworks. Python has a vast ecosystem of libraries specifically designed for data analysis and manipulation. This is going to include things like Pandas, for example. This is a very powerful library for data manipulation and analysis, especially with tabular data like your spreadsheets or CSV files. Now, number three, as to why Python is great for data analysis is the fact that it is integrated with other tools very well. For example, you have great database connections. Python is able to easily connect to databases like MySQL, Postgres, and SQLite to fetch and analyze data. You can connect to APIs. Python is able to interact with APIs to collect real-time data from external sources. For example, social media, financial data, web scraping, and more. You also have Excel and CSV files. Python can seamlessly integrate with files like CSV, Excel, JSON, and others, which are often used to store data. Number four on the list is data cleaning and transformations. Data cleaning is, of course, an essential part of data analysis, and Python's libraries, especially Pandas, provide efficient tools for handling missing data, removing duplicates, and transforming data into useful formats. And then we get to our next reason why Python is great for analyzing data, which is data visualization. Python's visualization libraries like matplotlib, Seaborn, and more allow you to create a wide range of visualizations from basic charts to complex interactive dashboards. Statistical and machine learning capabilities is the next item on our list. Python has extensive libraries for both statistical analysis like SciPy and stats models, and machine learning like scikit-learn, TensorFlow, and more. It's ideal for applying machine learning algorithms like regression, classification, clustering, and advanced deep learning techniques, making it a go-to language for predictive analytics. Now, one of my favorite and one of the most important reasons why Python is such a great language to learn is the community and support for the language. Python has a large and active community, which means there are plenty of online resources like tutorials, forums, documentation to help solve any problems that you might encounter. Then you also have flexibility and scalability. Python is highly flexible and can be used for small-scale tasks like quick analysis on a data set, as well as large-scale data processing. It also integrates well with cloud computing platforms like AWS, Google Cloud, and Azure, enabling the analysis of big data in scalable environments. Number 9 on the list is going to be the fact that it is open source. Python is free. It's open source, which means that you can use it without any licensing fees. Number 10 is going to be cross-industry use. Python is widely used in diverse fields, including finance, healthcare, marketing, engineering, and more, meaning skills in Python are transferable across industries. Number 11 on the list is popularity. Python was released in 1991 and was created by Guido van Rossum. Python has grown significantly since 1991, starting at version 0.9.0 with continuous updates, including in 2008 when Python 3.0 was released. Now that we have a good understanding of what is it that we're actually doing here today and why you might want to use Python for analyzing your data in your own organization or right there at home, it's time to just dive headfirst into our demo for the day. Now make sure that you download the class files that are inside of the description. Once you have those downloaded, if you haven't already downloaded them, is you are going to open up your browser of choosing. So I'm going to open up Microsoft Edge. You open up whatever browser that you would like, and this is going to be crazy. All you need to do to follow along is go to your URL and type out Jupyter.org. And when I say Jupyter, it's Jupyter. And then press enter. And you are going to be brought to the Jupyter homepage. The next step is we're going to hover our mouse over the try button up at the top of your screen. And you're going to select try. And you're going to scroll on down. And we're going to select Jupyter Lab. Now you can select it if you want, but do keep in mind, Jupyter Lite project is experimental. It says here it is a provided self-contained Jupyter environment that runs in your browser. It is an experimental technology that may have some bugs, so please be patient and report any unexpected behavior to the Jupyter Lite repository. But everybody should be good to go using Jupyter Lite. And so I'm going to click Jupyter Lab now, and this is going to bring me into the world of Jupyter. Now, this is truly amazing, y'all. We are inside of a Jupyter Notebook that's hosted on our web browser. Now, there are some limitations to this type of technology and the certain packages and libraries that you can bring in. It just so happens to be that we're not going to be running into any of those issues today. Just, of course, understand that this is definitely not going to be a tool that you use for any production type projects, but something that you can use to learn more about Python, about Pandas, and other libraries that are available here in this web-hosted Jupyter Notebook. Now, that being said, we are going to make our first step to getting into our demo. And that is going to be to come up to the top, and we're going to add in a new folder. All of these notebooks here are very helpful to get you started learning a little bit about Jupyter Lab and other items that are available here as well. We are going to open up a new folder. We're going to call this folder Python _ learn with the nerds and select enter. Now double click on this folder and you will be navigated inside the folder. Of course, there's nothing here yet. What you're going to do at this point is select the upload button up at the top. And you're going to be brought, of course, to File Explorer. And I want you to navigate to wherever it is that you downloaded the class files that, again, you can find inside of the description. Now, inside of your class files, you will see a folder called Sources. And I want you to double click on that, highlight all of the CSV files that are inside of that folder, and select Open. This will take just a moment. It's going to download these in. Now, you might be taking a look at the names of these CSV files and wonder to yourself, Zane, what are you getting us into? We've got fights, robots, teams, and tournament earnings. Well, I'm not going to lie to y'all. Python and other coding languages out there can be fairly boring to learn about. But this is Pragmatic Works, and you're hanging out with Zane today. So we're going to have some fun with our data set, and we're going to be talking about an underground robot fighting ring that we found. We're going to learn about the top performing robots. We're going to take a look at the different fights that they've been in. How many have they won? How many have they lost? How much have they earned in the tournaments that they're in? What about the best performing teams that we have here that all of the robots are associated with? So I hope that makes you excited because it's going to be pretty fun. Now that we've done this and we have our wonderful files loaded in, we are going to select this big blue plus button. And this is where you're absolutely welcome to take a look at the different items that are available here in Jupyter Lite, but we care about under Notebook, Python. And I want you to select that. Now, if you take a look at this and you're like, man, Jupyter Notebook are pretty cool. I would like to learn more about them. Well, we use them. And not only the live Python for Data Analyst Bootcamp, but I also have an on-demand learning class that goes through similar content that also uses Jupyter Notebooks. So take a look at that. You'll have the ability to have a lot more exposure and time working with Jupyter Notebooks in both of those classes. Now, that being said, we are going to talk just a little bit about what we have here in a Jupyter Notebook. Now, of course, this is Jupyter Lite, but it works pretty much the same way. A notebook, at least in the realm of Jupyter, and this goes for most notebooks that are out there, is just simply made up of different code cells. What I currently have selected is a code cell. It also has what's called markdown cells. Markdown is a very helpful set of syntax that allows you to easily format the text that you want to write or documentation that you want to use to document the code that you're writing. Documentation is one of the most important pieces of any coding language, whether it be for your own sanity 3 months later after you finished a project, go back to look at your code and don't know what you were thinking 3 months ago. But if you documented it properly, at the very least, you can read that documentation and feel a little bit at ease understanding what was 3 months ago Zane trying to do here. Even more importantly, when you're collaborating with other people, documentation is key because it allows others to read that documentation, understanding what they're seeing without having to sit there and read line by line, understanding what you have written. So notebooks are a phenomenal tool, not only for that, for education purposes as well as we're going through today. That being said, we're going to start with our first cell here. And our first cell is going to be reading in our data. So we have the CSV files that are right here, and we're going to read them in. But the first thing that we need to read in these files is going to be Pandas. Now, you can read in files using just basic Python, but it's a lot faster when we are using Pandas, which is primarily what we will be using today. So what I'm going to do is I'm going to type out import Pandas as PD. And this is one of the major ways that you're going to want to read in different libraries. You're importing some kind of library or package, and then you're giving it an alias, so PD. That way, when we use Pandas functions, we're able to easily see, as you will see in just a moment, where those functions are actually coming from. If you would like to execute this code cell, you are able to come up to the top and select Run right here, or if you're like me, go ahead and get your index fingers ready to go. You're going to hit Shift and Enter at the same time. It's going to execute that code cell, and then it's going to open up a new code cell for you to start writing in. So what we'll do now is I'm going to create what's called a data frame variable. Now, we'll explain what a data frame is here in just a moment, but for now, just go ahead and follow along with me. I'm going to type out robots df, standing for data frame. And I'm going to set this one equal to pd.read_CSV, open and close your parentheses, and we're going to pass in double quotes, and this is going to be our path. Now, because my files are in the same exact folder as this notebook, it's as simple as writing out the name of the file. And so I'm going to type out robots.csv. And I can select Shift, Enter, and that is going to read that file into a new variable. A variable, very simply, is a name that is storing some kind of value. That being said, let's continue on with the other ones. Let's do fights underscore data frame is equal to pd.read_CSV fights.csv. And I'm going to hit Shift Enter. Now, if I type just a little bit too fast for you, that is okay. You are absolutely welcome to go ahead and pause me if you ever need to take a moment to finish typing everything out. We have a lot to get to today, and I want you to follow along with me the entire time if you so choose, and I hope that you do. But again, if I go just a little bit too fast, just go ahead and pause me. I promise I'll be right there when you are finished typing out whatever you need to type out. Let's continue on here. Next, I'm going to do teams. Data frame is equal to pd.read CSV, and I'm going to pass in teams.csv, close my double quote, close my end parentheses, and hit Shift Enter. And then finally, our last one is going to be tournament earnings. So I'm going to type out for my variable name, tournament earnings data frame, and set that equal to pd.read CSV, and we're going to read tournament. Now just type out tour and then hit tab. It is going to open up for you IntelliSense, and that's going to tell me exactly what the name of my file is, and I'm going to select enter. Close up my quotes and my parentheses and hit Shift Enter. And now we have officially brought in all of these files, saved them into variables, and now it's time for us to take a look at the data. So this is one way that we can do so. In the same code cell, I'm going to type out display robots. Hit your tab button as much as you can. It's going to make it a lot easier for you to know exactly what you're looking for. And I'm, of course, looking for robots data frame without getting into any issues with spelling errors. All right, then I'm going to copy this, hit enter, and I paste this 3 more times. And I'm just going to go into the parentheses of all of these and change this. So this one will be fights data frame. The next one below will be teams data frame. And the next one below that will be tournament earnings data frame. Beautiful. Now, if you want to, and you don't have to do this part, but I'm going to actually come up here and I'm going to give some labels here. So this is just a quick and easy way to do this so we can take a look at our data for a moment. I'm going to print robots. I'm going to go above fights here. I'm going to print fights. I'm going to go above teams, and I'm going to print teams. And then finally, above tournament earnings, I will print tournament earnings, or tour earnings. And now I'm going to select Shift Enter. Oh, I got an error. Let's take a look at what this error is. Error messages are sometimes not the greatest because they don't tell you exactly what the issue is, but this one is a good error message. It says undetermined string literal. If I take a look, it says, hey, look at tournament earnings. There's something going on here. And if I come up to the top, I can see I didn't add in my end quotation mark. So I'll add that in, select Shift Enter, and we can now take a look at our data. So we have robots. Robots is going to give me information like the name of the robot. What is the weight class of the robot? What team are they a part of? What's their attack power, their defense rating, right? Then below that, we have fights. All right, so this is going to be tracking the different fights that have occurred. So it's going to give us a unique identifier of fight ID. It'll tell us who won, who lost, what was the damage dealt, how long did the fight last. We have teams. This is going to give us a team ID, the name of the team, engineer of the team, when was it founded, where is the headquarters. And then tournament earnings, which is going to tell us, all right, so for a tournament, there is a robot that has entered in or registered for that tournament. The name of the tournament is going to be provided. And at the end of that tournament, how much did that robot earn? So this is the data that we are going to be working with today. Now, I'm going to scroll up to the top here, and I'm going to select the top cell, and I'm going to come to the right. You can see you have some quick access or a quick access toolbar, and you have a little button here. It is a rectangle with a plus sign, and it says to insert a cell above, and I'm going to select that. Then I'm going to come up to the top here, and you can see that I have a drop down. It says code, and I have markdown. I'm going to select Markdown, and I'm going to come in here, and I'm just going to show you something very quickly about Markdown. Number one, it's very quick and easy syntax to learn. You can also use HTML syntax as well to provide the same effect as using normal Markdown syntax if you're familiar with HTML. So I'll come through here and I'll put in a header. I'm going to put in one hashtag symbol, which is going to be H1. Then I'm going to type out July, learn with the nerds, Python. There we go. Then I'm going to come down a little bit more. I'm going to add in 3 hashtags for an H3 header. And I'm going to label everything that we've just done here, which is ingest data. You can add in all of the notes that you would like here. In fact, I very much so recommend it. As you go through today's event, you can use Markdown as well as additional comments that you can use inside of a code block to let yourself know when you go back to this, hey, this is what I learned. This is something I need to work more on. This is something that I'm interested in. These are a few of the items that I would like to do after I'm finished up with the July Learn with the Nerds demo with Zane. So definitely super helpful. I recommend that you do that. But again, just to show you very quickly a little bit more about what you can do here with Markdown, I can come through and I can add in, for example, some HTML. So I can put in a span here, come to the end, put another span in. I'm going to come back to the first one, and you do not have to do this if you don't want to. I just want to show you a few items that are really cool with Markdown. And I'm going to add in a parameter here to the span. I'm going to say style is equal to color, green. Hit Shift Enter and take a look at that. We now have a colored H1 and we also have an H3 that says, hey, we just ingested some data. Now, that's not super important, especially for what we're learning today, but I just wanted to have a little bit of a tip there for you as to what you can do here inside of a Jupyter Notebook. I'm going to scroll down and we are going to get back to work. The first thing that I would like to discuss with you, when you're working with data here inside of Pandas, you are going to be loading in that data to what's called a data frame. So tournament earnings data frame is exactly that. It's a data frame. Now, there is a manual way that we can use to create data frames as well, but with the way that pd.readcsv works, it grabs the file and creates a data frame for us. Now, if you are completely new to Python and Pandas, then what you need to understand, and this really goes for anybody, what you need to understand about a data frame is that it is just like a table. So you think data frame, think table, y'all. Now, of course, it's Pandas. We're working with Python, a coding language, right? Which means there's going to be a lot more flexibility there. So there's more to what a data frame brings to the table. Pun definitely intended. That being said, we'll be able to see today a handful of those benefits of a data frame, but we're really going to focus on the fact that a data frame is just like a table because that is how we are going to treat it. We're going to have columns and we're going to have rows. I mean, take a look at the data that has been outputted to us. This looks just like a table. One of the main differences between a normal table and a data frame is that you can take a look here. You can see, of course, that we have the names for each one of our columns. But we also have 0, 1, 2, 3, and 4 on each of our rows. So you have 2 axes here for a data frame. You have your columns and you have your rows. Or what's used here to define those axes is 1 and 0. But when we take a look at 0, 1, 2, 3, 4, etc., that is called an index, right? So if you have any experience with just normal Python, that might be something that you can latch onto to help you understand that. But in reality, it's almost like its own unique identifier column, except it's just used in a bit of a different way than you might expect it to be used. So that, of course, is going to be our index. And the specific type of index that we're looking at here is called a zero-based index. It's not super important for you to understand exactly how that works right now, because we're going to go through some examples here in just a moment of what it looks like to filter your data. But basis information that you need to know now is that when we read a data frame or read a file into a data frame, or however we create the data frame, it is going to create not only our columns, which is also a type of index, but it's going to create an index for each of our rows. And yes, if you're wondering, if you read in 500 million rows. That means 500 million rows will have a unique identifier here via the index. And that points to a very important distinction to note about working with large data with pandas. You absolutely can, pandas and Python, read in large data. However, a lot of people will go towards something like PySpark, which you can take almost everything you learn here today and dive into PySpark there. But it uses the Apache Spark engine for efficient data processing, a lot of awesome things that go on behind the scenes to allow you to efficiently bring in 500 million rows and work with that data very efficiently. And so that's just a good piece of information for you to know about what exactly DataFrames are. But at the end of the day, just remember they are tables. I don't want you to get too confused or in the weeds when it comes to DataFrames. It's important to know, especially as you continue learning about this. But nonetheless, table is really the important takeaway here. So we're going to cover filtering. Now, there's a lot of ways that you can filter using pandas. Let's cover one of the most basic ways, which is going to be using what's called Boolean indexing. Boolean indexing is the act of filtering a data frame using some kind of Boolean condition. So we could filter a data frame, and that filter could be 1 equals 1. Well, 1 equals 1 is going to return either true or false, and that will be used to filter the result of that data frame. Let's actually use an helpful example to explain this one though. What I'm going to do is create a new data frame. And I'm going to create or call this data frame strong, I'll zoom in here, strong robots. Now, the goal of what I'm about to do here is I want to know for my robots who has an attack power over, let's say, 85. So how would we do this? Well, the first thing that we're going to do is add this to a new data frame because we want to be able to take a look at our data after we have provided the filter. And when we just simply provide a filter to a data frame, it will give us a result, but it's not going to be saved in any way. So we need to create a new data frame if we want to save it. And you'll see what I mean here in just a moment. If we're going to use Boolean indexing, what we're going to start with is calling the data frame we'll filter, which is going to be robots data frame. Then we are going to open up with square brackets and go ahead and close those square brackets there as well as a best practice so you don't run into any issues down the line with forgetting to end a quotation mark, end a square bracket, parentheses, whatever that looks like for you. Now, inside of this square bracket, you are going to provide your Boolean filter. And what I'm going to do is take a look at my attack power. But one of the things that I cannot do is just simply say attack power. I could not type that out because we need to understand, or at least Pandas needs to understand actually or specifically what column we're talking about. And right now in these square brackets, it doesn't have any context of what that data frame that we're looking at is. Now you might be wondering, well, Zane, here's the data frame we're looking at. What do you mean it doesn't have context? But I promise it should make sense for you here in just a moment. For right now, we're going to type out robots data frame again, and we're going to just put a period here, and I'm going to pass in attack power. And your IntelliSense after hitting tab should bring this up. Now, what I just did, it's called data frame notation or dot notation. And I'll show you the other method that we can use here in just a moment. But this is one method that we have to be able to call a specific column from a data frame. Then I'm going to use a greater than sign. I'm going to say robots data frame attack power. I want to make sure it's greater than 85. And that is going to be my Boolean condition. I'm going to select Shift Enter, and then I'm going to execute strong robots. And you can see here that I have two robots. I have Titan Fist and Iron Claw. It looks like the attack power for both of these robots are 95. And then of course for Iron Claw, we have 92. So it's a very simple method that we can use to filter our data. Just adding in a simple filter, and that is going to be using Boolean indexing. Now, I really like to take a moment here to explain what exactly just happened behind the scenes, and it's going to help us talk about a few other important pieces of Pandas as we go along. So what I'm going to do is I'm going to come up here and I'm going to copy robots You don't have to do this if you don't want to, just to use as an example. I'm going to copy my Boolean filter. I'm going to go to a new code cell, and I'm going to paste it in and execute it. Well, take a look here. We have true and false values here. It looks almost like a column. And then we also have 0, 1, 2, 3, 4, and so on. That is just like the index that we have in a data frame. Well, what this is actually a Pandas series. Now, remember when I said a data frame is just like a table, right? Well, what does a table include? It includes columns. And a table is made up of multiple columns, more than likely, of course. But if you were to take one of those columns and then remove it, well, in Pandas, what would that be called? That would be called a series. So when you think series, I want you to think column. It just so happens that just like in a data frame, when we were taking a look at a series, we also have an index, which means we have for each one of those column values in the series, a specified unique index for each of those values. Now, that is a series, again, just like a column, and a data frame is made up of multiple series or columns. Now, that being said, the reason why I copied the Boolean value here, Boolean filter, and pasted it here was to show you what is going on behind the scenes. For example, like why did we call robots data frame and then inside of the square brackets call robots data frame again? Kind of confusing, right? Well, the reason that that is required is because of the result of that filter. Take a look. It says true, false, false, true, false. When we filter using Boolean indexing on a Pandas data frame, it is going to take our statement here, which is looking at attack power, making sure it's over 85. It is going to go through that column and check each value. Is this greater than 85? For each of the column values in that column, if it is greater than 85, it will provide true. If it is not, it will provide false, meaning that we get an output as you see here. Then that series or column of true and false values is actually the item that will be used to filter robots data frame. So pretty interesting. It's basically going through and saying, include this row, do not include this row, include this row, do not include this row, so on and so forth. So very important distinction for you to understand exactly how it is that filtering is working behind the scenes, because it can be a little bit confusing as to why you have to do this in the first place. It almost seems as though all you would need to do is just pass an attack power greater than 85. But that is why we need to execute or call robots data frame more than once. It's simply how filtering works behind the scenes. Now, another question that you may have is, all right, Zane, I see that we filtered this data frame, but what if I wanted to just return one column from this result? How would I do that? Well, depending upon how it is that you're filtering, and we're going to take a look at some more examples, you're going to see that here in just a moment. Now, if I wanted to simply return one of those columns from this data frame, the first thing I need to do is understand that robots data frame, or this statement rather on the inside here, my Boolean filter, is going to return what you see right here. It is going to return the data frame. If I understand then that that data frame is going to be what is returned, then I can simply go to the end of my statement and open up two square brackets, and I can pass in the name of my column. Now, if you're wondering as to why I don't have to say robots data frame first, well, that's because, again, this statement right here is returning, or in fact, the entire statement here is returning the data frame, meaning I already have the context there telling me all of the columns that are available. Now, so I have robot ID here. I can select Shift Enter and Shift Enter again on strong robots, and we can see that we have the robot ID for both of those strong robots. Now, I can continue on with this, with a statement like this. If I wanted to, maybe bring in robot ID and attack power, I would not be able to come in, put a comma, and add in attack power. If I execute that, it's going to give me an error. The reason is that in Pandas, it is very important for you to be aware of what a different amount of square brackets actually mean. So if I am looking at a data frame and I use single brackets here to return one column, well, that is what it is going to be expecting. But if I'm trying to return a data frame, meaning more than one column, that I need an additional set of square brackets to identify that is what I am looking for. So robot ID and attack power, I have both set of square brackets. I hit Shift Enter again, and I now see a data frame. Now, this isn't the only way that we can query or select data using Pandas, but if we're trying to piggyback off of a filter statement such as this is one of the methods that we are able to use. Now, there is a lot more to filtering data. Absolutely. And in fact, even though we don't have time to talk about it today, I recommend to write down or just make a mental note of 2 additional items to continue researching on when it comes to filtering data with Pandas. And that is going to be lock and iLock. So that's ILOC and LOC. That uses the index that we've seen so far inside of a data frame to filter a data frame. They're very helpful, and depending on what you're trying to do, sometimes necessary to get the job done. Though we don't have time to talk about it today, I absolutely recommend that you take a look at the Python for the Data Analyst Bootcamp and the Python for Data Analysis On-Demand Learning class, where we do dive in to those 2 functions, iLock and lock. For now, we've taken a look at some basic ways that we can filter data. Sometimes when we are going to dive into merging or cleaning or just really doing anything to our data, we need to learn about it first. And so I want to go through some helpful functions that are available to you that can teach you about the data that you're working with in the first place. So the first thing that we're going to look at is what are the data types of all the columns in our data frame. The first one that we're going to take a look at is D types. So the first thing we'll do is call a data frame. So we'll say robots. If I could type, there we go, robots data frame. And then I'm going to type in a period, and it's going to be D types. D types. Hit Shift Enter. And this is going to show us what are the data types of the columns inside of our data frame. So we have robot ID, that's an integer. We have robot name, which is an object, and then the rest outside of weight class is also an integer. Object is a string. Simple as that. There is a specific string type, which comes from just normal Python. But when it comes to Pandas, it recognizes, especially when we're reading in data as we are now, a string data type as an object. That being said, that's how you can take a look at your data types, but there's additional functions available to you that will allow you to learn even more about your data. So let's take a look at robots data frame again, and we'll type out describe. And this is an executable. So we're going to open and close our parentheses. When I say executable, if you take a look at D types, we do not have any parentheses here, right? Because D types is basically just storing data that it already knows about, or really this would be considered metadata, which is data about your data. And it is simply storing that information. It knows what the data types are, so it's nothing that needs to be executed, right? But describe is going to give you statistics about your data frame. And this is something that needs to be executed. There's a logic going on behind the scenes that is going to look at all of our columns that can have statistics applied to them. It is going to run that type of operation or that executable. And that's why we need the parentheses here that defines, hey, this is an executable. There's some logic that needs to be run through here. So we can take a look at the count, mean, standard deviation, min, and so on and so forth about the data that we currently have inside of our Pandas data frame. Now, when we're working with Pandas and we're cleaning up our data, changing data types is definitely going to be something we need to do. And we can do that, of course. So let's use that object data type as an example. We're going to change this to a normal string data type. So I'm going to come to this code cell here, and I'm going to type out something interesting. I'm going to say robots data frame dot robot name. Now, and I'm going to set this equal to something. And the reason I'm going to do this is because just like when we were filtering data, we had that Boolean statement, right, which is going to return true or false, but we set that equal to a new data frame variable because otherwise it's not going to be saved. And so if we need to change the data type of a column in a data frame, then we're going to need to reinitialize that column in the data frame. So we're going to, first of all, say robot data frame dot robot name is equal to, and then we're going to repeat the same statement. So we're going to say robots data frame, data frame dot robot name, and we're going to use a method called as type. Seems IntelliSense does not want to work with me here just yet, but as type is what it will. Robot name, we're going to select period again, and we're going to pass in the method as type. I'm going to open and close my parentheses. I'm going to go back into those parentheses, and I'm going to pass in string as the data type that I would like to use. Then select Shift Enter. We can now take a look at robot data frame.dtypes again, and this is going to tell me that robot name officially has a new data type, which is string. It's a Python string. And it's just making sure that it is clear that we are aware of that. All right, y'all, so we've learned some basics. We've learned how do we filter data. Of course, we saw also that there are additional ways that we can filter data or select different columns. We've taken a look at the different ways that we can learn about our data using dtypes and describe, and even changed a data type of a column. But now I'm going to move into an additional piece, which is going to be grouping data. So grouping data, if you have any experience with analyzing your data, then you are going to have some experience with grouping in some way, shape, or form. If not, that's perfectly fine. Just stick with me here. To group data inside of Pandas, not only is it a common operation, but the syntax is really straightforward. What we're going to do is start walking through the process of getting the count of our winners. So we have our robots and all of the other information about the fights that they've been in, and we want to know how many have they won. So in this next code block here, we are going to type out a new variable name, and it's going to be called winners count. And we're going to set this equal to fights data frame. And just so that we can have some experience here again, I'm going to add in a code cell above, and I'm going to call fights data frame. And we can see here we have fight ID, the winner ID, loser ID, the damage dealt, and how long the fight lasted. Now, of course, remember, I'm currently looking for the amount of fights that my robots have won. But if I'm going to look at that type of information, I'm going to need to group by something that will allow me to perform an aggregation down the road telling me how many they've won. So I need to group by something. When you group in Pandas or many other languages, GUI tools out there as well, what you're actually doing is you're saying, all right, I've got all of these rows, and I'm going to now section off pieces of my table into groups, right? So we have group 1, group 2, group 3, so on and so forth. Now, currently, our data frame is one big group. It's just a big table. But if I provide a group, it is going to say, okay, I'm going to group by what we're about to do, which is winner ID. So we're going to have each of our winner ID robots in a group. So that means that for winner ID of 101 and 101 here, we have that robot in here twice. That's going to be a group. And then we'll do that so on and so forth with the rest of the winner IDs there as well. And then this is going to allow us down the line to perform some kind of aggregation to each of those individual groups. Again, at the end of the day, grouping is exactly as it states, grouping our data into sections. So let's do that. If we're going to group in Pandas, we have to start with, of course, the data frame that we are going to be using. Then we add in a period and we type in group by. Group by takes open and close parentheses, and it simply asks for the column that we are going to be grouping by. In this case, it will be winner ID because that is what we're looking for. If I execute this and then call winners count, it is going to give me a grouped object. So in Pandas, what it's doing is it is splitting that data frame into different groups, but we haven't done anything to those groups, so the process is not finished. And when the process is not finished, it is going to simply create a grouped data frame object. Now we have the ability to do something with this group. So I'm going to copy my statement up above and I'm going to paste it here. Now remember, we are now working with a grouped Pandas object. Again, meaning that we have grouped that data frame into those sections. Our next step is to provide an aggregation or aggregation logic to each of those groups. If I am going to provide aggregation logic, such as count, which is what I'm going to do, I need something to count by. So again, what I'm looking for here is for each of my robots, and of course I have winner ID, which is actually robot ID. It's just explicit in telling me that this is the robot that won the fight. I want to count fight ID. So this is similar to when we were filtering a data frame and then we provided those square brackets and applied the column that we wanted to bring back. This is working in a very similar way. This is saying for each of the groups, so again, let's take a look at winner 101 or robot 101. Robot 101 has won 2 fights from what we currently have logged. And so that means for that group, I'm going to count the fight ID column. And of course, in this example, to do this, I'm going to provide the aggregation function, which is going to be count. So we have our group, each of our winner IDs grouped together. Then we're going to count fight ID for each of those groups. And I can type out here winners count, and it is going to give me a series. Now, we're going to change this up a little bit. Something interesting happened here, but at the very least, you can tell that for 101, robot 101, well, that robot has won 2 fights. Again, just to reiterate one more time, we have each of our groups. Then we are counting the fight ID column value that shows up in those groups, and we're providing that value as the output. Now, what's actually going on here is pretty interesting. Sometimes you want this to happen, and sometimes you don't. We have actually ended up with the robot ID, aliased as winner ID here, as our index for the series. What that is going to tell you is that you do have the ability to change in a data frame or series what these values are, 0, 1, 2, 3, and 4, so on and so forth. You can change them to strings. You can change them to an additional column if you wanted to as well. And that's what it just did here for us. So we need to make a simple change. I'm going to go into my group by statement, and after winner ID, I'm going to pass in a comma, and we're going to type out as index equals false. False with a capital F. Execute both again, and what that did is it said, hey, Pandas, you took winner ID, which is the column that we're grouping by, and you used it as the index for the series that was returned. I do not want you to do that. I want you to return 2 columns, which is going to be winner ID and fight ID. Now, a distinction for you to be aware of, and this is going to make a lot more sense when we get into future aggregations here in just a minute, is that when we take a look at this statement here, and don't do this, but I'm going to remove this for a moment. This statement, as we saw a moment ago, returns a series. So when I tell you that there are different methods of aggregation in Pandas, the reason I say that it is important is dependent or is because of the way that we write out this code is going to change whether it's going to return a data frame or a series, which is going to have serious implications when we get to something like merging our data frames together. So do be aware of that. And of course, I'm going to provide you an example to explain that a little bit further. That being said, the reason that we know that it is a series is because we've made a statement, we've grouped our data frame, and we said for this specific column, I want you to give me a count. So for each of my winners, how many fights did they win? Count it for me. And it returned a series. Now, of course, whenever I provide as index equals false, it's going to change the function here just a little bit by providing to me that data frame. Now that that is done, this is only one piece of a larger question that I want to answer. I want to know, number one, out of all of the robots that are in these fights, for each robot, how many fights have they won and how many fights have they lost? So this is going to be one piece of the puzzle. So what I want you to do is copy winners count, come down below, and paste this here. If you would like, you can select enter here, go up to the top of your code cell and pass in a hashtag, and this is going to open up a comment. A comment is just a string that is not going to get in the way of the rest of the logic you're writing. And we can say this is a count of the fights the robots have won. And then we're going to add in a new code cell below. First, we do need to execute this, which will be Shift Enter, and then we can continue on. The next thing that I want to do, in fact, I'll even do it in the same exact code block. So I'll come back up here and I'm going to type out a statement that will rename my columns. So if I look up here, I see winner ID and fight ID, and that's fine. But winner ID is just an alias from the fights table that it's pointing to the actual ID of each of my robots. And right now, I would like to change the name of that column. There's, again, just like with everything we're working with today, multiple ways to do this. Easy way to do it here is as follows. You simply take winners count, which is the new data frame that we've created, and it has something called columns. And remember, this is similar to D types. It's not an executable. It's just a simple list of the different column names that we have for the data frame. And I'm now able to pass in square brackets, the names of my new column. So I'm going to pass in robot ID, and we're going to also rename fight ID to fights 1. And that's something to notice here as well. When we counted the amount of fights that were won, it kept fight ID as the name of this new column that we created. And of course, this is not the fight ID any longer. This is a count of the amount of fights that the robots have won. So this is going to fix that issue for us. So we have robot ID and we have fights 1. I'm going to execute this, press enter to enter back into this code cell below it. And we're going to write out the same or a very similar statement to get the amount of fights that each robot has lost. So this will be called losers. So this will be called losers count. And it will be equal to fights data frame dot group by. This time, what we'll be grouping by is going to be loser ID. Okay, again, we need the column that we're going to use to perform the aggregation, which is going to be fight ID. We're still counting the amount of fights in the data frame per robot, but in reality, we're looking at the robots who have lost each of those fights. Then we're going to pass in our aggregation function. And of course, we do not want a series to be returned here like we had above when we first executed this statement. We do not want the column that we are grouping by to be added as the index of a series. That's why we passed in as index equals false. But you have another function that is available to you that can do the same thing, which goes to the end of the statement, and it is called a reset index. Then I'm going to select enter, and we're going to rename these columns as well. We're going to say losers count dot columns is equal to robot ID and fights lost. We're going to execute that here as well. And we can display this. So we'll say display winners count and display losers count. So you can execute this and you'll be able to see, all right, so for winners count, which is the data frame at the top, we've seen this already. So robot ID of 101 has won 2 fights, so on and so forth. But we come down and we can see that robot ID of 102 has actually lost 2 fights. 103 has lost 1, so on and so forth. So this is helpful information to have. We've created successfully 2 new data frames that tells us what is the robot and how many fights have they won or how many fights have they lost. However, I want to bring this information together, especially because this is what we're going to be using to visualize our data very soon. So to do this, this is going to get into merging. Now, inside of Pandas, you have 3 types of merging data or joining 2 data frames together. You have merge, you have join, and you have concat. So merge is what we're going to be covering today. This is the merge that you know and love if you have experience with working with data. It is going to be required that you pass in a key column, something to join the 2 data frames on. That's very helpful, of course, but we are working with a data frame, remember, in Pandas. Remember, that means we have an additional element of flexibility and more that we can do. We have everything that we need to find out, hey, how many fights has this robot won and how many have they lost? So let's bring these together. I'm going to come down below here and we're going to create another data frame called win, loss, stats. And this is going to be equal to pd.merge. And you're going to open and close your parentheses. So inside of these parentheses, there's 2 major things that we're going to specify. The first is the left table that we are going to be merging on, and the right table will be the next piece of information that we pass in. So the first one will be winners count. The second table or data frame is going to be called losers count. And then we have some additional items that we need to specify. The first is on. So I'm going to pass on in. I'm going to set this equal to something. And I'm going to then set it equal to robot ID. On is going to say, all right, so you're merging these 2 data frames together. Which column are you going to merge these on? It's going to be robot ID. So it's going to take a look at both data frames. It's going to take a look at robot ID on both. See, hey, do these match? If they do, we're going to bring it over into the new data frame. If they don't, then we're not going to bring it over into the new data frame. Then, and of course, that is going to also be changed. The behavior will change a little bit depending upon what type of join you're going to use. In this case, I'm going to use an outer join. The way that we specify the type of join is using how. So how will these 2 data frames be joined together? You're going to set this one equal to outer. Now, the reason that we're using outer here is because there could be robots who have never lost a fight, and there could be robots who have never won a fight. And so when I'm joining these 2 data frames together, I want all of the information to be brought back to me, even if there's a robot that doesn't have a count of how many fights that they've lost because they've never lost a fight. I'm going to execute this and then bring back win-loss stats. This is going to return to me robot ID, fights won, and fights lost. Robot ID of 101 has won 2 fights. They've never lost a fight. 102 has won a single fight, but they've lost 2 fights. 103 is even Steven. Fights won is 1. Fights lost is also 1. What about robot ID of 104? Not doing so good this season. No wins, 1 loss. Now, we do have not a number values here. And even though there is a difference between the different ways that missing values can be represented, for example, you have null, not a number, and a, there are minor differences as to what that means. But in this context, not a number simply means that there is a missing value. And there are multiple ways that you can handle not a number or null values in Pandas. One of the very simple methods that we can use is win loss stats dot fill NA, and you can pass in 0 as the value that you're going to use to fill these null values with. And you can see that this has now been changed. So for fights 1, 101, still won 2 fights. As far as fights that they've lost, they haven't lost a fight. We go down to 104, fights 1, 0, never won a fight, but we have lost 1 fight. So fill NA is just scratching the surface, by the way, as far as the different methods that are available to you for handling null values inside of your data. This is very simple, passing in 0, but of course, when you get into more complex data frames, then you might want to be a little bit more granular with how you are filling those null values, and you absolutely have that capability here inside of Pandas. Now, one of the additional items that I would like to accomplish here before we finish up this example is sorting my values. So let's take a look at how we would do that. The first thing I'm going to do is call win-loss stats. I'm going to pass in a function called sort values. This is also open and close parentheses. And the first statement or piece of information that it's going to want to know is what are we sorting it by? And we're going to set this equal to square brackets. We're using square brackets because we can pass in one column, we can pass in multiple columns. In this case, we're just going to pass in fights 1. That's what I want to filter by. Then you pass in a comma. And if we want to change whether this is going to be ascending or descending, we can do that. First thing to understand about that is by default, when we're sorting, it is going to do it in ascending order. So if we want to change that to descending, then we need to pass in ascending equals false. Shift enter, and we can now see that we have fights 1 being what it is sorted by here up at the top. Now, I will say that you can see that we still have our not a number or missing values here. And the reason for that is because when we're using these functions that fill null values or not a number values, we again would have to reinitialize win-loss stats by typing in the name of the data frame or a different name if we wanted to change that. It's very common practice. That's what we would need to do in order to keep that change there. But I'm going to leave it as it is for right now. And we are going to continue on. So we've learned a lot in what we've just finished up. But again, I told you a moment ago that there are multiple ways to aggregate data inside of Pandas. And one of the major ways or methods that you'll use to aggregate data is going to be using the .ag function. Because we are performing these aggregations on a single column, right? We're counting fight ID. And that does create a new column for us, which is fights 1 and fights lost. But oftentimes, you're going to want to perform multiple aggregations, right? And so the .ag function will be used anytime that you're going to be creating multiple aggregated columns or calculated columns. So let's take a look at what that would look like. The first thing I'm going to do is bring tournament earnings back into the mix. So tournament earnings again tells us the robot ID. It tells us the tournament that that robot was in, and then how much that robot earned in that tournament. Understanding this, I would like to figure out how much each of my robots have made in tournaments. And I would also like to figure out what is the top teams as far as earnings go. So I need to merge these two data frames together. I want to know, again, the amount of earnings per robot, and I want to know what is the top team that we have. What are the top teams, right? A list of all my teams. And that is going to, of course, depend on how much each robot has earned. But I have a little bit of a problem. And that problem is that between these two, I don't have anything that's tying my robots to each team. Now, of course, I know these robots are a part of these teams, but the data frame that contains that information is actually in the robot's data frame because it tells me per robot which team are they a part of. So the first thing that I'm going to need to do is merge tournaments with robots. That way, later, we can bring teams into the mix. So let's get this statement done. Let's merge these two data frames together. To start, we're going to go through and create a new data frame. And this will be called robot earnings data frame. And this will be equal to pd.merge. The left table that we'll join on will be robots data frame. The right table will be tournament earnings data frame. It will be on, so the key column that we'll be joining on will be robot ID. And the method that we will use to join them together or merge them together will be enter. I'm going to hit Shift Enter here and execute robot earnings data frame. And you can see here for each of our robots, again, we used an inner join here. So if there's a robot in the robot's data frame that isn't in a tournament, then we're not going to worry about that robot because we're focusing on tournament earnings. And vice versa, if there is a robot in tournament earnings, but that is not in our robot's data frame, then that's not a robot a part of our organization, you could say. That being said, we now have all of the information that we need to continue on. We know which robot is a part of which team and how much they have earned in that particular tournament, as well as additional information that can be very helpful as well. Of course, like I said earlier, what we're going to be looking for here is calculating the sum of all of the earnings that each robot has made. And then, of course, we're going to apply our team's data frame as well to get information about our teams. That being said, I'm going to have an issue. If I take a look at robot earnings data frame and I take a look at the types, the data types, I can see up at the top that earnings is a string. But that is what I'm going to be summing here in just a moment. And as you could probably tell, summing strings is not going to be very helpful. And besides, we're going to need to change this to an integer, but it will still cause some issues for us because, well, we have special characters. We have a currency symbol and a comma, which we'll need to get rid of. I'm going to type out my robot earnings data frame, and we are going to select a very specific column, which is going to be earnings. Now, I was showing you earlier data frame notation, which is using a period and then typing out earnings, which would work in this case. But do know that you also have the ability to use open and close brackets here, and then in quotes, pass in the name of your column. This is very helpful in the case that you have column names that have spaces in them, where you would definitely need to use a method such as this. It will give us the exact same result. And we're going to set this one equal to robot earnings data frame. We're going to call the same column here, which will be earnings. Again, because we need to set this column equal to its new or changed value. In this case, we're just changing the data type, and we're going to remove those characters. And then we're going to use a function called replace, because we need to replace those special characters with something else. In reality, we're replacing it with nothing. However, when you're working with columns in a data frame and you want to access a string function, as we are doing right now, you have to provide what's called a string accessor. All it is a statement that says, hey, I'm working with a data frame, specifically a column in that data frame. There are many functions that are available to me when doing so. But if I want to access a very specific function that is only capable of being used with a specific data type, in this case a string, then I'm going to need to pass in period str for string. I can then access the string functions that are available to me, such as replace. I'm going to open and close my parentheses, and then I'm going to pass in a regular expression. Now, I absolutely recommend that you do some research on regular expressions. Oftentimes, if you're trying to perform some kind of data cleaning operation and you think that a regular expression would help you, then just look it up and see what you can find. It's not something that you have to commit to memory, but do be aware that they are helpful, and you'll see why as we write it out right now. So in the replace function, I'm going to pass in R, single quote, square bracket, money sign or currency symbol, backslash, comma, end square bracket, single quote. I'm then going to pass in, after I put a comma, what am I replacing those values with, which will be just single quotes. Nothing in it, so no white space, no spaces, just nothing. It's basically is what we're saying. Another comma, and we're going to pass in regex or regular expressions equals true. Now, this statement here is very interesting. Basically, what it's saying is, hey, look, we're using a regular expression, and here is a list of the values that we want to remove. Backslash here is more of an escape character, and we're basically saying, hey, the currency symbol and the comma is what we would like to get rid of, and we're going to replace it with nothing. And then we have to pass in that regular expressions is equal to true, so it will properly read and execute our statement. Finally, at the end, now that we have officially removed those special characters, we can pass in our final statement, which is as type, and pass in int. Execute this, take a look at robot earnings, and you can see that not only are those special characters removed, but if I pass in dtypes, you can now see that earnings is an integer here as well. Do be aware with Pandas, there's definitely some nuances to the different data types that are available to you. As you can see, this was defaulted to an int 32, and you have robot ID up here that was defaulted to an int 64. Just be aware of that. We can officially start the process of adding the ag function into the mix. So let's do that. The first thing that we're going to do, as we've done a few times now, is create a new data frame. And this is going to be called total robot earnings data frame. And this will be equal to a statement that we've seen before, which is robot earnings. Remember, robot earnings is that merged data frame we just created. Dot group by, and in our group by statement, we're going to pass in robot ID. So currently, with what our statement says is that we have robot earnings data frame, which is what we see right here. And we are going to group this data frame by robot ID. So 105, this is a perfect example. 105 and 105, Shadow Viper. This right here is going to be a group. And we're soon going to be able to see how it is that we might be able to, for this group of robot ID of 105, add 2,800 with 1,800. Now, this is where we are going to add in the ag function. Remember, the ag function is the function that you can use to add in more than one calculated column at one time. Now, you might be wondering, we've only really discussed adding in one calculated column, but you'll see why we're using ag here in just a moment. I'm going to pass in .ag, and I'm going to open and close my parentheses. This is where formatting your code comes into play. I can now go into my parentheses, and I'm going to press enter, and it's automatically going to indent me here right below total robot earnings, and I can now start passing in my new columns. Now follow along with me here, because this is going to be the syntax you'll follow with the .ag function. The first step is going to be adding in what is going to be the name of the aggregated column. Our first aggregated column will be called total robot earnings. Then you set this new column equal to some value. The value that you pass in will be an open and close parentheses, also called a tuple. We're first going to pass in the column that we are going to be using for the aggregation, which will be earnings. The second argument that we pass in will be the name of the function that we'll use to aggregate, which will be sum. Now, do keep in mind that these are going to need to be in quotes. And by the way, you also are able to add in very specific functions here as well, if you so choose to add in even additional or more complex aggregation logic. I'm going to leave this as it is. So we're saying for this new column, total robot earnings, we are going to sum up the earnings for each robot ID group. Then we're going to add in an additional column. When you want to do this, you're going to go to the end of that statement and pass in a comma and press enter. Now this is going to be something interesting. I'm going to pass in team ID. And I'm going to set this equal to open and close parentheses, our first value being what is going to be the column that we're using in the aggregation, which will be team ID. And then we're going to pass in the aggregation function, which will be first. Now this is interesting. The reason that we're doing this statement right here, is because when you are using the .ag function, it is going to return to you, as you'll see in just a moment, if I select Shift Enter and then total robot earnings data frame, it is going to return to you only the columns that have been used either in the group by statement or inside of the aggregation. And so that means if I removed this statement, and you don't need to remove it, and I remove that comma, then you can see that total robot earnings and robot ID are the only columns that are added back. And do keep in mind that robot ID was made to be the index like we've seen before when we're just aggregating one column. So I can come back up to the top here and I can put period and we'll say reset index. And there we go. That looks better. But to continue with my explanation here, with me not having team ID inside of either the aggregation or in the group by, it is not going to include it. So the result that I get is robot ID, as you can see here, and my new column, total robot earnings. Now, normally that's not a problem, right? Because this is the information that we're looking for. We can see that for robot ID of 101, they have earned a total of $5,000. Pretty neat. However, I said just a moment ago that one of my goals was to also find out information about my teams. And so if I want to add in my team's data frame, well, then I'm going to need my team ID inside of this data frame that we see here. One of the ways that we can accomplish this task is with what I did just a moment ago when I added in team ID here. Now, this is not always going to be a solution to the problem that you might encounter, but I will explain briefly how this is working behind the scenes. So what first is going to do is it's going to take what we see here, our robot earnings data frame. It's going to look at that data frame, specifically the robot ID. So we're going to come up to the top and we're going to say, okay, here is robot earnings data frame. We're going to look at our groups. So for our group of robot ID 101, what is the first instance of that robot being associated with the team? So it's going to look at this row. It's going to see the robot ID is 101. What is the team ID? It's going to add it then to the data frame. All right, what about 103? A better example. It's going to take a look once it gets to robot ID of 103. It's going to say, all right, what is the team ID for the first instance of robot ID 103 being in the data frame? All right, team ID is 3. Now, this works perfect for us only because our robots in this data frame never change teams. They never change teams. And that means that for robot ID 103, in the second time that it's in the data frame, it's still going to have the same team ID, so it's not a problem. It would be a major problem, and this would not be something that you could use in the event that you were tracking not only the robots and the teams that they are currently a part of, but if you were tracking in the same table the teams that they used to be a part of. Because if all of a sudden for this particular tournament of Mech Madness, Volt Striker with robot ID of 103 was on team ID of 3, well, if Volt Striker changed teams during the Hardware Defiance tournament, then it's never going to account with how we currently have the code set up for that change in teams. So do be aware of that. At the end of the day, that statement first is going to look at the data frame that we're using. It's going to take the column that we are grouping by. It's going to find the first time that it is found inside of that data frame. It's going to look at the team ID and use that in the new data frame that we're creating. That works perfect for our situation, but it would definitely cause problems in another situation where, again, we're tracking also in the same table when our teams or when our robots have changed teams. Just do be aware of that. That being said, though, now that I bring this back, I can now see that I have a team ID associated with each one of my robots and the amount of times or the amount of earnings that they have summed up for all of the tournaments that they have been associated with or a part of. All right, so we have a huge piece of the puzzle here, and we're almost done. But I did tell you that I wanted to do something with this team ID, and so that's exactly what we're going to do now. So what we're going to do is we are going to incorporate our teams into this data frame, total robot earnings data frame. We've already said that, yes, it's true, we were able to get the total amount earned in tournaments per robot. So technically, that means the result that we have in total robot earnings has been grouped, right, by robots. That's what we did with the .ag function. Well, that's great. But now what we need to do is group by the teams. That way, not only can we see, hey, what did robot 101 make in all of the tournaments that robot's been in, but also maybe robot 101 isn't the only person in that particular team. If there's 3 robots, we want to see how much collectively have they all made for the team. So this can be a little bit tricky to handle, even though it may not seem like it, and I'll explain why. But the first thing that we're going to do is just simply add in a new column, an aggregated column, to total robot earnings data frame. And we'll see the complexity that we're going to dive into as we walk along. So the next code cell, we are going to start, of course, as we have before, with bringing up our total robot earnings data frame. Now we're going to use square brackets. That way we can grab the name. Let me zoom in a little bit more here for you. That way we can grab the name of the column that we're looking for. And we are going to be looking for the total team earnings. But you say to me, Zane, total team earnings doesn't exist here. And you would be right. Because not only can you use this syntax to select specific columns in a data frame, but you can also use it to create new columns, which is what we're doing here. So we're creating a new column. It's called total team earnings. And we're going to set this equal to a value. This is going to be equal to another grouped object. So we'll start this way. Like before, we're going to bring up total robot earnings again. Then we're going to group by. And what are we going to group by in this instance? Well, we already know the answer. That's going to be team ID. Now, remember in the beginning, when we started looking at filtering a Pandas data frame, we mentioned how whenever you are filtering a data frame, you can select to bring back one column or more than one column as well. But when it comes to aggregating, we're also able to do the exact same step, which would be to add in 2 square brackets at the end of our grouped data frame object. And inside of these square brackets is where we're going to provide the particular column we're going to use in the aggregation. Better said, what are we going to be summing up, which is going to be total robot earnings. So we'll bring total robot earnings. Then we're going to come to the end of this statement, and we are going to do something that is going to be incorrect. But stick with me here for a moment. I'm going to say dot sum, and as we've seen already before, we're going to take our data frame and we're going to group by teams. All right, so this is going to look very similar to some of the results we've seen already. Per team, we're going to be able to see how much is it that that team has made. Of course, that's because we're summing up total robot earnings here. But there is a major problem with this. If I select Shift Enter and then return total robot earnings again, I'm going to see some very odd behavior. I have all of my robots, I have the amount that they have made, and I have the team ID. So nothing's really changed there. But the total team earnings column that we've just added in has some large oddities here. Not only do we have not a number of values, but if you went through and you calculated some of the math on adding up the amounts that the robots have earned in these tournaments, you would see that there's some anomalies there as well and some bad math. The reason that this just happened is because of the way that we are trying to smush these two data frames together, or in reality, one column into an existing data frame. Let's explore this further. So if I scroll up, I can see total robot earnings data frame. This is what we are currently trying to add a column to. It is grouped by our robots, and that means that we have per row one individual robot. That's perfectly fine. But if I were to come down and take a look at this right here, I'm going to copy out the grouped and aggregated statement here, which in this case is going to return a series, because whenever you are adding a column to a data frame, it has to be a series. Remember, that's what a column is going to be in this example. Well, let's go ahead and pop a new cell up above here. If I bring this back, let's execute it just as it is, take a look at the issue that has presented itself. As you might expect, it is going to group everything by the team ID. But if there's only 3 teams, which there are only 3 teams, then we're only going to have 3 rows. And that is going to accurately calculate how much that team has made from all of the times one of that team's robots have been in some kind of match. But the problem enters whenever we take a look back to total robot earnings data frame, where you can see that we have a different amount of rows. And so when we try to take this statement here and smush it right into total robot earnings data frame, these two objects, the data frame and series, are grouped differently. They have a different amount of rows, and things are just simply not going to match up appropriately. So what would be the solution then? We need to add in this new column into the existing total robot earnings data frame. But how are we going to accomplish that? Well, to diagnose the problem, the reason that our statement here, which is again aggregating or summing up the robot earnings for each team, the reason that we have a smaller amount of rows here or column values is because we have collapsed the groups, meaning that if we have team ID, which we do if we come up and look at total robot earnings, if we have more than one team ID in more than one row, well, that's going to be collapsed into one row, and it's going to sum up $5,000 with $4,100. Now, that is to be expected. That's not necessarily saying that something has gone wrong here. It just means that we need a different solution. Again, the key thing that I said there was that this statement has collapsed the groups, making 2 rows now into 1. But if we would like to keep total robot earnings as it is, then we still need to group by the team ID. We still need to get the sum of total robot earnings. But the piece that we're missing is doing it in a way that does not collapse the groups. Doing it in such a way that if team ID of 1 shows up in the data frame twice, that it still shows up at the end of the result in that data frame twice. The way that we're going to do this is using a very interesting method of aggregation, which is the transform method. So let's take a look at redoing this, but this time the right way. I'm going to scroll on down, and we are going to copy the statement that we've had above here. But this time, like I said, we're going to be doing it the right way. And we really don't have to change much of anything. Follow along with me here. Again, we're adding a new column called Total Team Earnings to the Total Robot Earnings data frame. We're going to come over to the right side. The definition of this new column is grouping by team ID and summing up total robot earnings. But the way we're going to sum up total robot earnings is just a little bit different. So go ahead and get rid of sum. You're going to leave that period there, and you're going to type in transform. Then you're going to open up two parentheses, and in those parentheses, you're going to pass in sum. Simple as that. And if you would like, you're welcome to clean this up a little bit, format it a little bit better. You can use that escape character, of course. You can even go in the middle of a statement. For example, if I wanted to go before group by and press enter there, well, it's going to run into an issue if I try to run this. So you just use that backspace as an escape character and you'll be good to go. Let's go ahead and format this as I had it. There we go. Give this a little bit of an indent and let's keep going. So that was a very small change. I'm going to press enter here and I'm going to bring back total robot earnings. And would you take a look at this? We have something very similar to what we've seen before. Actually, the only thing that's changed is that a new column has been added, which is exactly what we wanted. But this time, we don't have just 3 column values here. Now, we have all of those values for each team and each robot. This is what we were looking for. It did not collapse the groups, and now we're able to see that robot ID of 101 is on team 1, and the total earnings for team 1 is $9,100. It's very important with all of the different ways that you have to aggregate your data in these data frames to pay attention to exactly what are you joining together. Is it a data frame in a series? Is it a data frame and a data frame? And then, of course, when you're aggregating, that's important to keep mindful of with how are your groups collapsing. Very common practice to need to do something like this where we just need to simply add in a new column, but you just figured out how to get past that issue if you find yourself dealing with it. Let's continue on though. We're almost done. But I want to cover something very quickly, which is visualizing your data. We've gone over some basics. We've ingested data. We've been able to select specific columns. We've been able to filter our data, change our data types, merge data frames together, add in very specific columns, learn about the different methods of aggregations and the nuances between them. And even though there's so much more to learn in between all of those steps, there is a piece of the basics that I would like to share with you, and that would be visualizing your data. Now, depending upon your skill set, you absolutely might be somebody who wants to leverage Python and its libraries like Pandas to simply and efficiently wrangle your data, right? Ingest it, transform it, and then load it somewhere. Then you might want to use a graphical user interface like Power BI to visualize your data. And that's absolutely valid, and you should absolutely do so. But do be aware that you have the ability to use code to also visualize your data. And it definitely gets complicated, so do be mindful of that. But nonetheless, I absolutely want to share with you a very simple visualization that we can use with the win-loss stats that we created towards the beginning of the demonstration. The start of this process is going to be importing that library. So follow along with me here. We are going to import matplotlib.pyplot as PLT. You can go ahead and select enter here. And we are going to, I'm going to use a comment, create a bar chart. Then this is all going to be in the same exact code cell. I'll explain why here in just a moment. The first thing that we're going to need to do is specify how big this plot that we're creating, this visualization, is going to be. So we are going to use plt dot figure, and that is going to take an open and closing parentheses, what's called fig size or figure size. And that'll be equal to another set of parentheses. And we'll say this is going to be 10 by 6. Now that that's done, I'm going to use more than one bar chart here, of course, because remember, we're tracking for each robot the amount that they've won and the amount that they've lost. So I'm going to be very specific with the size of my bars. So I'm going to create a variable called bar width, and I'm going to set this one equal to 0.35. That will make more sense as to why that matters here in just a moment. Then for a bar chart, we are going to provide a new variable called x. And this is going to be equal to a range, which is another Python function. Open and close your parentheses. Then we're going to use a length function called len, open and close parentheses. And inside of len, we are going to provide the win-loss stats data frame. Now, what this is going to do is it's going to, number one, get the length of our win-loss stats data frame, right? So how many rows are inside of that data frame? And then it is going to provide that to a function called a range. And I will execute this. And just to show you what I'm talking about here, if I execute x, this now gives me a range function from 0 to 5. That being said, I'm going to come back up to the top. I'm going to go below x, and I'm going to create a new comment. And this comment will be plot wins and losses side by side. And this is where we get into the fun stuff. So the first thing we're going to do is plot out the first item that we're going to be measuring here, which is the fights that have been won. So let's do that. We're going to pass in plt.bar, of course, because we're creating a bar chart, open and close parentheses. The first thing that we need to know is how is it that we're going to be plotting the x-axis? And that is going to be using the variable that we created, x. And you'll see why that matters in just a moment. We're going to pass in a comma, and we're going to give it our y data, our y-axis data, which will be win-loss stats. We're going to use those square brackets and then pass in fights won. So now we know how many fights have they won. That will be shown there on the y-axis. And then we are also going to know here as well, how is x going to be positioned? Where is this going to be positioned on that x-axis? Then we're going to provide some additional information here. So we'll provide the width of the bar. And that is, of course, going to be equal to bar width, which is the variable that we created up above here. We're going to give this a label as well, and this label will be equal to fights 1. And then we're going to pass in the color for this bar, which will be equal to green. Let's keep going here. Oops, I forgot my end quotation. And we're going to come down below again, and we're going to say plt.bar, and now we're going to be tracking the fights that have been lost. Open and close your parentheses. And we're going to use a very special function that's helpful for this particular visualization. Again, this is much more so to introduce you to what it looks like visualizing data with Python. So this is definitely getting into some complicated territory, I know, but stick with me here just to show you an example of what a visualization with Matplotlib might look like. We are going to use or open up square brackets. You're going to open up your square brackets and go ahead and just write this out with me. We are going to say for I in X. And I'm going to go to the back here right before the for statement. And I'm going to say I plus bar width. Now, this is a complicated statement. I know, trust me. I don't expect you to absolutely understand what's going on here. But this is what's called a list comprehension. So it's going to take this statement and say for I in X, meaning it's going to iterate through X. And remember, there's a range of numbers there, 0, 1, 2, 3, 4, and so on. It is then going to say, all right, well, I, which is going to represent a number in that range, plus the bar width. And that is going to be the position of each of the bars that represent the losses for the robots. The reason we're doing this is because for each robot ID on the x-axis, we're going to have 2 bars, and we need to be able to position them appropriately. Let's continue on. So that's our x-axis, and then for our y-axis, we'll say win, loss, stats. This time it'll be fights, lost. We're going to set our width equal to bar width again. Our label will be equal to fights, lost. And our color will be red. Let's do red. Okay, press enter here, go down just a little bit, and this is the logic. And we're going to visualize what this is going to look like here in just a second, which will hopefully help make some of these items make a bit more sense to you. Let's continue on here. We are going to now start to provide some additional information for this visualization. So we are going to, I'm going to make a new comment here. We're going to set X ticks and labels. And you'll see what that means as we go along here. So we'll say plt.xLabel is going to be equal to robot ID. plt.ylabel is going to be equal to number of fights. plt.title of the visual itself will be equal to fights won and lost by each robot. plt.xticks will be equal to something we've just seen a moment ago, a list comprehension. So stick with me on this one. In our square brackets, we're going to say for I in X. We'll go to the back or behind of 4, and we'll say it will be I plus bar width divided by 2. And then we'll say win, loss, stats, robot ID. Finally, we'll say plt.legend so that we can use the legend based off of the labels that we've provided. And then we're going to use plt.tight layout. And then finally, plt.show. Now, the reason why all of these items need to be in the same code cell, they don't have to be, but keep in mind, we're not necessarily using plt inside of a variable name. That means that plt, or short for plot, is using the current plot state of what we're working with. So if we have this split up and we say plt bar, and then we have a couple code cells down, the second plt bar, if we go to show that, it's not going to know what we're talking about. It doesn't know the context. So having everything together here is going to be what you want to see. So let's go ahead and hit Shift Enter on here, and I'm going to zoom out just a bit so we can take a look at what we can see. So now look at this. I have a visualization. I have not only a legend up at the top, fights won and fight lost, so green and red. I have a title here, fights won and lost by each robot. My y-axis and my x-axis are labeled, and I have my bar chart, or my individual bars, positioned exactly where I want them. So just to kind of explain a little bit of this in a better way now that we can visualize what we're seeing. Number one, we needed to make sure, because we're using a bar chart with 2 bars for one individual piece of data, that being robot ID, we needed to ensure the placement here of those bars. And so that meant that when we said where it is that this bar is going to show up on the x-axis, we wanted to ensure, number one, that they did not interfere with one another. So in our statement here where we're covering fights lost, we, of course, used a list comprehension to change just ever so slightly the position of that second bar. Then down below, xticks is going to tell the visual or matplotlib exactly where 101 should show up, 102, 103, right? We have to be very specific with where these are going to be placed, these pieces of data. And so xticks is saying, hey, take the bar width, add the value of I from x, which is going to be 1, 2, 3, whatever it may be, and then divide it by 2. And in reality, what it's saying is, all right, we have 2 bars. I want it to go in the middle. That's what it is currently saying. And we are specifying that for each one of our robot IDs. Of course, we went through and we have made sure to label everything. Everything is looking great. And by the way, this is just scratching the surface. Not only can we make this look even prettier, but we can add in another library called Seaborn that gives additional functionality as well. And that completes our Python demo, everybody. I hope that you've enjoyed today's session. I hope you learned something, maybe one thing, maybe 2 things, dare I say, maybe even 3. Don't forget, you've stuck around with us until now, so you should be redirected to a live Q&A session where we can talk about Python together. Also, keep in mind, of course, that in the chat, there should be a link that pops up that brings you to that same Q&A session. I'll see you here in just a moment.